Sketch two circles that touch at point T. From any 2 points A and B in circle 1, extend AT to meet circle 2 at Q and BT to meet circle Q at P. Draw the tangent at T to both circles and label it SR. Prove that AB is parallel to BQ. So I can see this is going to be two circles touching at a point in the middle and then a crossover. That will be the two lines extended through A and B. So that's what it looks like to me. So I'm just going to draw what I think it looks like. And just like yesterday, I'm going to deliberately do a bigger and a smaller circle. Although, yes, that's bad. Now there's a circle and an egg. It's a snowman that's fallen over. Okay, so there's point T. And in circle 1, so I'll call this one C1. I'll have A and B there and there. That makes sense to me. And I'll extend BT through circle 2, and BT meets circle 2 at P. And I'll extend A through T to circle 2, and that meets at Q. Draw the tangent T to both circles and label it SR. So the tangent will be like that, and SR here. And it lacks a bit of clarity in which way SR go, but it shouldn't actually matter. Prove that AB, so this line here, is parallel to PQ. And let's have a look at the diagram. That's what the diagram looks like. So what we need to show, and this is similar to yesterday, is we need to show, I'm going to map through, that if this is angle X, then we need to show that this is angle X, and that will be two corresponding angles. That's the plan. And the way I'm going to do it is by recognizing that these two are equal. That will work. Vertically opposite. And I'm also going to recognize that this is equal to that. Alternate angle theorem, alternate segment theorem, sorry. And that means that this is actually equal to X. So that's nice. Oh, if that's equal to X, then this is equal to X. And if that's equal to X, then the other one's equal to X. They are a bunch of alternate angle theorems with a vertically opposite in the middle. This is actually pretty easy. So I can say angle RTB equals angle TAB. This is alternate angle theorem. So it's not alternate angle theorem, it's alternate segment theorem. That's the first one. Then I can say angle RTB is also equal to angle STB, and this is vertically opposite. And I can also say that angle STB is equal to angle PQT. This is alternate segment theorem. And therefore angle BA, or I've done TAB. TAB equals angle RTB equals angle STB equals angle PQT. And so, angle TAB equals angle PQT. And therefore AB is parallel PQ as angle TAB and angle PQT are corresponding. So STB, it should be STP. Yes, it should be. Don't ruin me. Okay, there we go. So I'll fix those up. So just be careful with those. But in all, and this is probably not something I should record on a video, but I'll do it anyway. I like that you error check that, and I'd like you to be considerate of your own work. But in terms of time allocation and then exam, if you did what I just did, chances are I and most markers probably wouldn't pick up on it. They would see that you've tracked the right way, and your labelling might be slightly wrong. You don't want to make heaps of mistakes, but if you made one mistake that flowed through, they probably wouldn't even notice. So if you get time, check, make sure that you haven't made a mistake in case. But if you were going to allocate time to checking, it might be better allocated somewhere else. Throwing it out there. So there we go. That was, I hadn't done that, and you can see how easy that worked out, but it just took a bit of time. And you can see the blue and the green on my diagram is my thinking. I'm going to be able to show this, I'll show that, that'll work. And then by just playing around with the question, I came up with a path in purple. So the last example for today, example 8, which I'll give a bit more room to as well. Prove that when two circles touch, their centres and the point of contact are collinear. So this is another non-diagram question. So let's draw two circles that touch. Wish me luck. There's a circle 1. Oh. There we go, look at that. Okay, they're not really circles. This is now a fallen over snowman on a pillow. There's the two centres. I'll call this centre O1 and I'll call this centre O2. Hopefully you'll agree if they touch at this point T, they have a common tangent. So we'll call this tangent, I'm going to change the point T to there so we can see it. That's their common tangent, and hopefully you'll see that the radius to the tangent will be a right angle, and the radius to the other tangent will also be a right angle, which implies that O1T O2 must be a straight line because you've got two right angles on it making 180 degrees, and you only get 180 degrees in a straight line. So if I call this S and R again, like the previous question, I can say if T is the point of contact, which it is, because that's given in the question, then, so it's an if-then statement, SR is a common tangent. So it's a bit of a pain, but you see how I'm making every statement? I'm making sure that every part of my proof is shown. And now I can say, therefore, angle STO1 equals 90 degrees. This is the angle between a tangent and radius, and angle STO2 equals 90 degrees for the same reason. I'm just going to be lazy and do that, and you can do that in your exam. I don't mind if you use the same reasoning there. And therefore angle O1, that's Q, O1 TO2, you laugh, but it's really frustrating for me that I can't seem to handle writing things that I'm saying. O1 TO2 is 180 degrees, which implies a straight line, and this is the requirement for collinearity. O1 TO2 collinear. Here we go. Any questions apart from how do I live with myself? Again, no, a good diagram, some time taken just to build in and understanding the question, and I can see that that falls into place. At no point have I told you that 3 points are collinear implies that the angle on them is 180 degrees. You have to go back to some basic geometry sometimes and recognise 180 degrees implies a straight line, which implies collinearity. So you have to probably take that on yourselves, and that might come up. But other than that, that's the second example 8. I'm going to change the labelling so it becomes example 9 now. Thanks.
More complex questions.